Right now, as you listen to this, something is crawling across the face of the sun that we haven't seen in more than a decade. A giant wound. A swirling patch of darkness so large it could swallow 10 Earths and still not be full. It emerged only hours ago, as if the sun were slowly revealing a secret it never meant to show us. The moment it appeared, alarms lit up. NASA was watching. NOAA was watching. Every space weather observatory on Earth swung its instruments toward the same region. Because if this goes wrong, we are looking at a kind of event the modern world is not ready for. Officially, this monster is catalogued as AR4294-4296, a sunspot complex so vast that it had to be split into 3 numbered regions just to track it. It is roughly 5 times taller than Earth and 5 times wider, and it is rotating into a position where it is staring straight at our planet. Amateur observers report that, with a proper solar filter, you can see it with the naked eye, something that almost never happens. And here is the question almost no one wants to say out loud. What happens if it blows? What if the largest sunspot of the decade decides to release its energy precisely while Earth sits in the crosshairs? By the end of this story, you'll understand why scientists are preparing for sleepless nights over the next 72 hours, and what a true worst-case scenario would actually look like. The sun is not a calm, friendly light in the sky. It is a gigantic fusion reactor, a churning ocean of plasma where magnetic fields twist, knot, and snap. Sunspots are the scars of that chaos, dark only because they are slightly cooler than their surroundings. At about 3,500 degrees Celsius, they are still hot enough to vaporize every structure humanity has ever built. The group that appeared on December 1st, labeled AR4294-4296, is extreme even by solar standards. It is so large that it takes nearly 2 days just to slide past the visible limb of the sun. What keeps scientists on edge is its magnetic configuration. The most dangerous sunspots are those where opposite magnetic polarities are crammed into a tight region, like a spring twisted to the breaking point. This giant did not appear in a quiet era. Solar Cycle 25, which many expected to be modest, has overshot most forecasts. Sunspot counts have surged. In August 2024, activity reached the highest levels seen since 2001. On November 11th, region AR4274 unleashed an X5.16 flare, accompanied by a rare G4 geomagnetic storm. Now, on top of that, the largest sunspot of the decade is turning to face us. On the very day AR4294 emerged, a smaller region, AR4299, produced an X1.9 flare strong enough to trigger an R3 radio blackout over Australia. For about 30 minutes, high-frequency radio on the dayside hemisphere went silent. Just 8 minutes after the flare, a pulse of radiation hit Earth, and a high-speed coronal mass ejection, CME, was recorded. It missed us, barely. As the sun continues to rotate, AR4294 is moving into its most dangerous alignment with Earth. Forecasts now show roughly a 70% chance of M-class flares between December 1st and 5th, with a real possibility of additional X-class events. On December 3rd and 4th, G1 to G2 geomagnetic storms are likely, and a KP7 storm could push auroras as far south as Chicago and Melbourne. But the real concern is not the minor storms. It is what AR4294 might be capable of. Its Delta-class magnetic structure hints at a huge reservoir of stored energy. If those fields reconnect suddenly, the release could equal billions of nuclear bombs. The X-rays are only the first flash. The true danger is a CME, a billion-ton cloud of charged plasma that can slam into Earth's magnetic field, compress it, and drive currents strong enough to damage power grids, knock out satellites, disrupt GPS, and cripple the internet. The next few days will decide whether AR-4294 is merely a spectacular sight or the seed of the biggest space weather event of the decade. December is opening with a solar warning. In a world bound together by electronics and infrastructure, the stakes are far higher than they were in 1859. And the sun, as always, is indifferent. Less than 17.5 hours after astronomer Richard Carrington sketched a strange solar flare in 1859, a CME hit Earth at incredible speed. Telegraph systems in Europe and North America sparked and failed. Telegraph paper caught fire. Auroras glowed as far south as the Caribbean and Hawaii. It remains the most powerful geomagnetic storm on record. The damage, however, was limited, because the world was not yet electric. Today, the situation is very different. The grid is the invisible bloodstream of civilization. It powers clean water, hospitals, transport, telecommunications, factories, and global supply chains. In the United States alone, a modern Carrington-scale storm is estimated to cause $600 billion to $2.6 trillion in damage. The weak links are roughly 2,000 ultra-high-voltage transformers that hold the grid together. Each weighs hundreds of tons, is custom-built, takes more than a year to produce, and has almost no spare replacement. Lose a few in the wrong locations, and an entire region could be dark for months or even years. In 1989, a storm only about one-third as strong as Carrington collapsed the Quebec grid in just 92 seconds. Simulations suggest that a Carrington-level storm today could swell the upper atmosphere by hundreds of %, increasing drag on satellites, pushing some out of orbit, knocking out communications, degrading GPS, and crippling our ability to track space debris. We understand the basic sequence. A flare ionizes the upper atmosphere, and a CME drives a geomagnetic storm. But understanding the mechanism is not the same as being ready for it. And Carrington is not the worst the sun can do. In 2012, researcher Fusa Miyake discovered a sharp spike in carbon-14 in tree rings dating to the years 774 to 775, about 20 times higher than normal background levels. The evidence points to a superstorm of charged particles, at least 10 times more powerful than the Carrington event, possibly much greater. Similar Miyake-type events have occurred several times in the Holocene, with one about 14,300 years ago, estimated to be roughly twice as strong again. If a Miyake-level storm struck today, radiation at cruising altitudes could become hazardous. Satellites could fail almost instantly. GPS could go dark for days. Induced currents in long power lines could push grids far beyond their design limits, triggering damage that spreads faster than any existing response plan. Ancient records describing ominous red crosses in the night sky are now believed to be low-latitude auroras, signatures of storms so strong they painted the heavens over regions that almost never see auroras. These events are real. They recur. Statistically, we may be living in a time when another major event is possible. Now, imagine a fast CME aimed directly at Earth. Images show a full halo CME leaving the sun at over 2,000 kilometers per second, fast enough to reach us in under 18 hours. Warnings go out to utilities, airlines, and satellite operators, but most people never hear about it. Forecasts suggest a strong but manageable storm. Then, it arrives earlier than expected, and its magnetic field is oriented exactly the wrong way, opposite Earth's. The magnetosphere is compressed. Huge currents are induced in long transmission lines. Transformers begin to saturate and overheat. Protection systems trip. Lights go out. In the first hour, it feels like a major blackout. Annoying, but familiar. Then, mobile networks begin to fail. Backup systems strain. Communication becomes local and patchy. No one is sure how big the outage really is. By the second hour, transport systems are snarled. Signals fail. Accidents rise. Hospitals switch to emergency generators. Some critical equipment is disrupted by electromagnetic interference, and staff are forced back to manual procedures. By the fourth hour, the scale is obvious. Entire regions are dark. GPS is unreliable or offline. Airlines cancel flights. Financial markets cannot open. Refrigeration stops. Water still flows, for now. By the 12th hour, phones die as batteries drain. Rumors replace reliable information. That night, for the first time in decades, major cities experience true darkness. Inconvenience hardens into quiet fear. By 24 hours, water pressure falls as storage tanks empty. Supermarkets run out of bottled water. ATMs and payment systems are down. Cash suddenly matters again. By 36 hours, fuel becomes scarce. Gas stations can't pump. Trucks sit idle. Cold storage fails. Food begins to spoil at scale. Supply chains fracture.
By 48 hours, the damage is clearly beyond quick repair. Key transformers have burned out. Replacements will take months or years. Utilities prioritize power for hospitals and critical infrastructure, but overall capacity is crippled. Transmission lines and control systems are damaged. 2 days without electricity is not the disaster. It is the door that opens into it. If power returns within a week, societies bend but do not break. If it takes months, everything changes. Food shortages worsen. Water service becomes intermittent or collapses in some areas. Disease risk rises. Social order frays. Government and industry reports have warned for years that losing even a handful of critical transformers could trigger a nationwide grid collapse, with recovery measured in years, not days. And beneath all of this is the most fragile system of all: water. Every pump, filter, sterilizer, sensor, and distribution line in a modern water network runs on electricity. When the power stops, every liter you drink is a liter that is not being replaced. Tanks and reservoirs can buy time, but eventually taps run dry. Once the water stops, the cascade accelerates. Hospitals struggle to sterilize equipment and cool machines. Firefighting becomes nearly impossible. Sewage backs up. Waste accumulates. Pathogens spread. Humans can adapt to candlelight, but we cannot survive more than a few days without safe water. Providing emergency water on a national scale is almost impossible. A city of 1 million people needs roughly 1 million gallons per day. Moving that much clean water without fuel, functioning roads, or working logistics is a fantasy. Natural sources are often contaminated, and purifying water requires fuel and supplies that will quickly run short. After 4 to 5 days, mass casualties begin, not from solar radiation, but from the secondary collapse of sanitation and public health. History shows how civilizations fail when critical systems crack.
The Maya struggled with water management. The Norse in Greenland could not adapt to climate change. The Late Bronze Age collapsed when many small systems failed together. Complexity is powerful when it works, and fragile when it breaks. Our civilization is the most complex ever built, and it depends utterly on two things: electricity and clean water. A large CME does not have to destroy all technology to trigger a rapid cascade of failures. This is not a prophecy. It is a warning. Adapt or endure. The Inuit survived in the Arctic by staying flexible. The Norse, who refused to change, disappeared. Flexibility is survival, whether in climate, resources, or space weather. We already know the risks. We know the Carrington storm happened. We know that in 2012, a powerful CME missed Earth by about 9 days. Had it erupted a week earlier, we would be telling a very different story. We know the grid's weak points. A few thousand ultra-high voltage transformers that take 18 to 24 months to replace. Analyses suggest losing as few as 9 in the wrong places could trigger a nationwide blackout. We also know that hardening the grid and stockpiling key equipment is technically possible and relatively cheap. Tens of billions of dollars, a fraction of military spending. What is missing is not the engineering, it's the will. AR-4294 itself may never produce a catastrophic CME. It might cross the solar disk, throw a few impressive flares, and fade away. But the Sun has produced Carrington-scale and Miyake-scale events before, and it will again. Whether we are ready when that happens is entirely up to us. The Sun does not care about budgets or politics. It follows the laws of physics. One day, a large CME will be aimed directly at Earth. When that day comes, everything you've just heard stops being a thought experiment and becomes a live situation. The largest sunspot of the decade is now turning toward us during the most active phase of solar cycle 25. Forecasters are watching every twist of its magnetic fields, hoping that tension will be released gently instead of violently. Tonight, if the sky is clear, look up. The same star that makes life possible may also pose the greatest challenge to our technology. Understanding that isn't fear-mongering. It is the first step toward resilience. Thank you for listening. If this made you think differently about our place under the sun, share it so more people become aware of this overlooked risk. And if you want to keep exploring the science and mysteries that will shape our future, you're welcome to stay with us. The universe is speaking. The sun is speaking. The question is whether we're willing to listen.